with the automatic assembly technology of industrial robots becoming the current research hotspot of intelligent manufacturing in China. The teaching of industrial robotics courses has received more and more attention in major universities. However, in traditional industrial robotics courses, students' participation is not high enough. Practical experience is lacking, and the teaching effect is very little due to the high risk of practical operation and the small number of students in robots. Scientists from WIMI Hologram Academy of WIMI Hologram Cloud Inc. discussed in detail the introduction of VR technology into the industrial robotics curriculum to explore a new model of combining reality, and to realize a new model of classroom teaching and learning. The goal of the project is to break the limitations of traditional industrial robotics teaching, accelerate the reform and innovation of teaching content, curriculum, teaching methods and operation mechanism, and fill the gap of industrial robotics practice teaching. The development of VR technology is a great fit with the industrial robotics teaching process, and can be used to make the classroom truly virtual and real with the help of instruments and equipment and other material conditions to achieve the leap from perceptual understanding to engineering practice. For example, VR technology can be used to model virtual simulations of industrial robots for assembly and maintenance, to identify possible defects and problems in the initial stages of the design process and reduce unnecessary waste. Another example is the virtual calculation and design of the process of robots used for automatic drilling and riveting of aircraft, which can enable students to match the realistic manufacturing process. Another example is the use of virtual assembly technology, which enables students to realize the overall arrangement and coordination of large aircraft in a more realistic and natural environment, complete with simulation of the robotic assembly process as well as maintenance and testability simulation. Industrial robotics is a highly interdisciplinary subject, which integrates many professional knowledge such as mechanics, cybernetics, electronics, computer science, etc. The theoretical knowledge is abstract and closely connected with engineering applications, so the course is also more practical and needs to emphasize the combination of theory and practice. In the teaching, students are not clear about the basic concepts of robotics. The classroom participation is not high enough, and the lack of hands-on robotics experience seriously affects the cultivation of engineering practice and innovation ability. The main reasons are as follows. 1. Traditional experiments only support repetitive cognitive experiments, and cannot carry out highly exploratory experiments of industrial robots combined with large aviation parts manufacturing, which directly affects the improvement of students' innovation ability. 2. Due to factors such as large aircraft assembly experimental sites, large equipment, large parts, and complex processes, it is difficult for schools to replicate industrial robot equipment manufacturing sites. 3. The danger factor of real robot practical operation large. There is a certain safety risk to carrying out industrial robot-related teaching experiments. 4. Aviation large parts manufacturing experiments need to constantly upgrade large professional equipment and tooling, consuming a lot of expensive experimental materials. Coupled with the physical robot is also more expensive. The cost of physical experiments is extremely high. In the face of the number of students and the number of robots is small, it is difficult to use actual robots as experimental equipment for teaching and training. Therefore, exploring new teaching modes has become an inevitable trend for industrial robotics curriculum reform. This paper takes automatic aircraft assembly process of aerospace manufacturing engineering as a typical case, establishes a VR teaching platform based on industrial robot intelligent assembly equipment, and explores a new mode of combining VR technology and industrial robot teaching. The VR platform is designed to explore a new model of combining VR technology and industrial robotics teaching. It transforms industrial robot programming, accuracy compensation, trajectory planning and automatic drilling and riveting of aircraft assembly robots, which depend on large test sites and equipment, into a practical course, so that students can experience the operation and programming of industrial robots and their cutting-edge applications in aerospace manufacturing without leaving school. This paper focuses on the construction of an industrial robotics teaching platform that combines reality and imagination, the innovation of an industrial robotics curriculum that combines reality and imagination, and the exploration of the content of an industrial robotics curriculum that combines reality and imagination. The construction of the virtual real industrial robot teaching platform is divided into two parts, virtual and real. The virtual part mainly relies on VR experimental equipment as the basis to build an industrial-grade 5G wireless LAN and fiber optic data transmission platform to realize multi-terminal and low-latency data sharing, so as to achieve the purpose of centralized teaching and interactive experiments for multiple students in the virtual environment. The real part relies on the existing industrial robot equipment with different loads in the laboratory, allowing students to understand the structural characteristics of the robot in a realistic environment, so as to better bring students into the virtual world for aircraft assembly, robot drilling and riveting experiments. In this paper, we propose to adopt a three-dimensional experimental teaching method, focusing on the student-centered approach, paying attention to the difference of different students' acceptance of the virtual real teaching method, adopting different motivational methods for different students, arranging differentiated experimental objectives, and grouping and assigning tasks according to students' abilities. In addition, we will realize diversified ability cultivation in the teaching process, taking basic theory as the starting point and gradually bringing in engineering scenarios to realize the cultivation of students' technical exploration ability, and in the process, cultivate students' analysis ability and innovation consciousness of engineering problems. The teaching content of the course will also focus on the combination of basic theory, advanced technology and experimental operations, breaking the traditional classroom format of teachers lecturing and students listening to lectures, realizing the interactive teaching of teachers and students to explore together, and innovating the teaching mode of equal communication between teachers and students and mutual assistance and cooperation among students. The content of VR-based industrial robotics course mainly includes three aspects: basic theory, experimental teaching and engineering application. The basic theory includes the development history of industrial robots, robot kinematics, dynamics and control methods, etc., which lay the theoretical foundation for the subsequent experimental courses and engineering applications. The experimental teaching includes two parts: the virtual real experiment and the robot hands-on experiment. The virtual reality part will guide students to operate the virtual robot in the laboratory environment with the help of virtual reality equipment, which not only achieves the experimental effective industrial robot operation teaching, but also avoids the possible harms to students and experimental equipment caused by misoperation. The robot practice aspect relies on the existing small load industrial robots in the laboratory to realize the transformation of students from VR experiments to actual operation experiments. Since the operation skills have been mastered in the virtual reality experiments, the experimental efficiency can be significantly improved in the practical operation link, saving a lot of teaching costs and teaching sites for purchasing industrial robots. After students have fully mastered the operation skills of industrial robots, they will be led to enter the virtual world again to explore the application of industrial robots in aircraft assembly, with industry frontier issues as group topics assigned to individual student groups, thus cultivating students' ability to analyze and solve engineering problems and improving their comprehensive quality in all aspects. VR technology can certainly refresh students and increase their interest in learning, but in the teaching process, the teacher's reasonable teaching method is an important factor in determining the quality of teaching. In the teaching process, teachers should be more aware that technology is only an auxiliary tool to improve the quality of teaching and learning. Teaching to pay attention to technology but not rely on it in the process of teaching and learning, to give students a wide space to express their ideas, encourage and guide students to actively think an innovative culture. The industrial robot teaching platform with VR technology as the core integrates the specific objective industrial robots into VR technology, which requires the establishment of a general VR framework and the integration of the detailed characteristics of industrial robots to form an overall platform architecture. Firstly, the VR framework development engine is established, and the product number model of the 6-degree freedom industrial robot is built by using professional modeling software, and the product number model is further optimized and reduced in surface by combining with model optimization software tools in the industrial design field and imported into the engine as the final model. Kinetic model to completely transplant the characteristics of the real industrial robot into the VR robot. Finally, establish the corresponding human-computer interaction rules in combination with the specific use scenarios of the teaching platform, and determine the specific VR equipment configuration, stereo glasses, virtual helmet, etc., with students as the center, so as to finally realize the human-computer interaction and information flow between the industrial robot and the operator in the VR immersion environment. based on the teaching platform of industrial robotics based on VR technology. With the immersive characteristics of VR technology, we change the teaching methods, explore the application of new technologies in teaching and talent training work, and plan the teaching ideas and methods of industrial robotics based on VR technology as a whole. Firstly, VR technology is used to provide students with virtual scenes that are close to reality, and teachers play the role of guidance and instruction in virtual scenes to guide students to acquire relevant knowledge in the virtual scenes. Finally, for distance learning needs, VR can be used remotely to provide teaching resources for students, and teachers can realize remote instruction, assistance, testing and evaluation through the teaching platforms to provide guarantee for teaching quality. High-quality teaching resources information construction is the basic premise for colleges and universities to cultivate high-quality talents. And the teaching platform with VR technology as the core pays more attention to the construction of basic teaching resources. First of all, based on the existing courses, sort out all the involved experimental equipment and related teaching resources. Ensure the full coverage and practicality of teaching resources. Secondly, use the school enterprise joint and other channels to develop advanced network cloud storage technology for teaching and experiment. Ensure the information storage service of massive teaching resources. Finally, with the professional requirements as the guide, in the actual teaching with typical work tasks as the main body, the use of modern information means construction of teaching experiment platform, construction of learning, practice, examination, all-round learning and assessment system, to achieve efficient use of teaching resources and sustainable development. The reform of training methods is an important part of the reform of student teaching and training system, and VR technology needs to take student training as the core and use various advanced teaching methods to realize the training of high-quality talents. First, for the existing industrial robotics course teaching system, analyze the advantages and shortcomings of the existing teaching mode methods. Make reasonable teaching mode corrections to the course with the help of VR technology, and realize the wide application of VR technology in the course training. Second, combine VR technology, use computers and sensors and other related teaching resources. Set up typical cases of industrial robot processing and manufacturing based on VR technology, and improve teaching quality. Finally, according to the students' mastery and evaluation indexes in the course, the feasibility and practicality of the teaching model will be comprehensively evaluated, and the original training system will be combined to make corrections to the student training system and complete the reform of the teaching and training system. This paper has explored a new model of teaching industrial robotics based on VR technology, designed the teaching content of the industrial robotics courses integrating VR technology, and proposed a research method for teaching industrial robotics courses. The deep integration of VR technology with industrial robotics curriculum is conducive to cultivating students' diversified abilities and meeting the needs of innovative learning. Unlike traditional cognitive teaching, VR technology as a teaching platform can realize the interaction between students and the knowledge they learn, and complete the personalized teaching transformation from teacher-centered to student-centered. It can also improve students' ability to analyze practical engineering problems and to use industrial robots to manufacture products with low cost and high efficiency.